Welcome to Programming Methodology, the Architect's Guide to C. This video introduces the foundations of the C programming language, bridging algorithmic blueprints to structural code. Programming involves a hierarchy of communication. High-level languages like C focus on human logic and readability. These are translated by an assembler into machine-level raw signals, the binary code executed by the CPU. C uses a compiler, which translates the entire source code into a standalone executable file at once. This results in faster execution. Interpreters, like those used for Python, translate and execute line by line, stopping at the first error. An algorithm is the logic design, a clear, unambiguous, finite set of steps to solve a problem. It must be language independent, have well-defined inputs and outputs, and be feasible. Flowcharts are the visual schematics of an algorithm. They use standard symbols like terminators, parallelograms for I/O, rectangles for processes, and diamonds for decisions to show the flow of logic. C was developed by Dennis Ritchie at Bell Labs in 1972. It is a middle-level language, balancing high-level logic with low-level machine control. It's structured, efficient, and used for systems like operating system kernels. The program development workflow involves several stages: writing source code in an editor, handling directives by the preprocessor, converting code to object code by the compiler, combining with libraries by the linker, and finally, running the program via the loader/execution step. IDEs automate this pipeline. The anatomy of a C program includes the preprocessor directive, such as !hash include less than stdioh greater than the main function where execution begins, a function call like printf braces to define blocks, and a terminator, the semicolon, to end a statement. The raw materials for C programming, the character set, include letters, digits, white spaces, and special characters. These characters combine to form tokens, the smallest individual units in a program. C has 32 fixed, reserved keywords that must be lowercase, such as !int, if, and void . Identifiers are user-defined names for variables and functions. They must start with a letter or underscore and cannot be a keyword. Variables are named memory locations whose values can change. Declaration reserves space, assignment fills the space with a value, and initialization combines both declaration and assignment in one step. Constants are fixed materials with values that do not change. Examples include integers, real or floating point numbers, characters, and strings. Strings are arrays of characters ending with a null terminator. Primary data types include !int, for whole numbers, !float, for real numbers with decimals, !char, for single bytes, and double for large, high-precision real numbers. Qualifiers like !short, or signed, modify the size and range of these basic types. The interface for console input/output requires including stdio.h. C treats all I/O as a continuous stream of bytes. Input devices send data via stdin, while output goes through stdout, or stderr. Formatted output uses the printf function. It takes a control string, which includes literal text and conversion specifiers like %d, and arguments whose values are inserted into the string. Escape sequences are special characters preceded by a / to control cursor position, such as and for a new line, or for a horizontal tab. Formatted input uses the scanf function to read data from the keyboard. It requires format specifiers that match the variable type and the crucial address of operator, and to indicate where in memory to store the input. Unformatted character I/O uses getcher, to read one character, and putcher, to display one character. This method is simple, fast, and does not require format specifiers. For string I/O, gets str, reads an entire line, including spaces, but be aware of the risk of buffer overflow. Puts str, prints a string, and automatically adds a new line. The foundation is now laid. You are ready to build, having defined the logic, set up the environment, structured the program, and understood how to handle interaction via I/O functions.